All right, so 9.5. Distance from a point to a line in R2, okay, so two-dimensional space, and R3, three-dimensional space. So going back to grade 10, you guys learned the distance between a point and a line. And we say the distance, but really we mean the shortest distance, right? And we know that the shortest distance is always which line? If we're looking for a shortest distance from, okay, so let's put it this way. So I have a line and I have a point, and I want to know the shortest distance from the point to this line. How do I know which one it is? Is it that one? Is it that one? What's the shortest distance? Sorry?
Perpendicular.
Yeah, it's the perpendicular. And we know that because of the Pythagorean theorem, right? We know that the hypotenuse is always the longest side, and any other line that I draw that attaches to this line is going to be a hypotenuse. So we know that the perpendicular distance is always the shortest one. And so that's the concept that we're going to be talking about here today, okay? So distance from point Q to the line AX plus BY plus C equals 0, so in standard form. So here's my point. And I know that the distance is going to be the perpendicular distance. So that's why that's my D right there. It's my perpendicular distance. And we're going to use the concept of projections because that distance is what? What type of a projection is that distance? Do you guys remember? So if I take that red line and I project it onto that normal, that's your distance, is it not? Hello, is anybody there?
Yes.
Okay, good. I thought I lost you guys again. So I hope you guys can see that. So here, look at this line, okay, or this vector. So now if I take the projection, right, and we know that to find a projection, we just drop a perpendicular here and it's that distance in green. So it's basically just the scalar projection of QR, okay, onto the normal. Okay, or PQ, I should say. I think we called it PQ. I apologize. QR is our distance. Okay, any questions? So I'll label my point here. We called this Q. Okay, so distance is equal to the magnitude of, or the scalar projection of PQ onto the normal, right? We know that the scalar projection is a scalar, right? It's already the magnitude. So it's the distance of that projection. And so my formula here is PQ dotted with N, the magnitude divided by the magnitude of the normal. Okay. Yeah.
The diagram. Why is there two Qs?
No, there's not two Qs. There's one Q. Oh, excuse me. There is two Qs. That's P. I apologize.
Okay.
Thank you. There you go. PQ. So PQ, the projection of PQ onto QR. Okay. All right. So here, PQ dotted with N. Well, if I have 2 points, X1, Y1, or X0, Y2 as my second, then I know that PQ, you just subtract the 2 components. So X1 minus X0, Y1 minus Y0, dotted with AB, because we know that from the Cartesian equation, AB will give us the normal, right? And then we divide by the magnitude of the normal, which we know is the square root of A squared plus B squared. Okay, again, from our Cartesian equation. So now, when I clean this up, I get AX1 minus AX0 plus BY1 minus BY0 all over the square root of A squared plus B squared. And then I have this expression here. And you guys have seen us do this before in another equation. What am I going to call this? Constant. Constant C. Okay, C because we're talking about Cartesian equation of a line in 2 space, right? So AX1 plus BY1 plus C there's my Cartesian equation. We're taking the magnitude of that divided by the square root of a squared plus b squared. Any questions? And so there's your formula. Okay. So the shortest distance is always the perpendicular distance. Distance from a point to a line into space is that formula right there from the Cartesian equation. So let's do an example. Determine the distance from K, they're giving us a point, -2, 3, to the line 4x plus 5y minus 6 equals 0. So 4 is A, 5 is B, and -6 is C. And we just sub into the formula. Subbing in my point. So there's my exact distance, 1 over the square root of 41, or if I ask you, you can approximate it. Okay, and that is the distance between the point K and the line. Any questions? So it's just this formula. Okay. Determine the distance from the point Q to the line with this symmetric equation. Now, we don't normally look at symmetric equations in 2 space, do we? We normally only do them in 3 space, correct? So from here, all you need to do here is cross multiply to get your Cartesian equation. And here I have minus 12 plus 5. So there's my Cartesian equation. Once I have the Cartesian equation, again, I'm just subbing into the formula. So ABC is right there, 6, -5, -7, and you sub in the point. Over the magnitude of AB. All right, and here we have -18 minus 10 minus 7 all over the square root of 36 plus 25. -35. And so we know that it's just 35 over root 61. And in approximate form, 4.48. Okay. Are there any questions? Okay, example 3. Calculate the distance between the point Q and the line R. So distance between the point Q and the line R. What should I do? We're in 2 space. Remember, we're in 2 space. So what should I do?
Find the Cartesian equation.
Yes, good. And I can very easily see the normal here, right? The normal is just 6, -5, negative reciprocal, right? We're in 2 space, so that's very clear to see. And so my Cartesian equation will be 6x minus 5y plus some constant, and I sub in the point. And so here I can see that C is equal to 12 minus 5, bring it over, -7. And then from here, guys, just subbing into the formula. So 6, my point is 0, -3. So 0 plus 15 minus 7 all over 36 plus 25. Sorry. Okay. And I can't remember if if the book rationalizes here. I'd have to double check. I will double check. I can't remember if the textbook rationalizes. I have a feeling they leave it in decimal form. But anyways, what is the decimal here? I don't have it. What's the decimal here? 8 divided by root 61.
1.02.
Thank you. Okay. Now, I'm going to show you an alternate to finding Cartesian form, okay? You guys have never learned this before, but for those of you that will be taking linear algebra in first year, you will learn it, and it's called the determinant. And what it is the cross product in 2D, okay? So, if you have PQ, 2, 1 minus 0, -3, those were the 2 points that we had, right, from above. So, subtract them to get your PQ, you get 2, 4. Our direction vector is 5, 6. And here, notice, I've taken 2, 4 and written it vertically right there. And then 5, 6, and I write it vertically here. And then you do your cross product. So 2 times 6 minus 4 times 5, and it gives us -8. Okay? And then you can go ahead and continue with your formula. You already have your distance, and you just have to take your a squared plus the square root of a squared plus b squared. Okay, so that's, sorry?
I have a question about that form.
Sure.
So is there any like specific benefit to using the alternative form?
The determinant? Not really.
Yeah.
No. I mean, it's used in other applications, but no, not really. It's just another way. It's just a cross product in 2 space.
Is there going to be like questions that specifically ask for?
No, just showing you. It's sort of just like an FYI, because you will, like I said, for those of you that will take linear algebra, you'll definitely see it.
Okay, thank you.
Yeah, no problem. Okay. All right, so distance from a point to a line in 3 space. Okay, so what's the problem here? Why can't I use the same method that I just used before, or the same formula? Distance from a point to a line in 3 space. What's the problem here? Do we have a Cartesian equation of a line in 3 space?
No.
No, we don't. That's the problem. So my other formula relies on knowing the Cartesian equation. So now we're going to look at a different formula if you're finding the distance from a point to a line in 3 space, okay? And from here, guys, if you take a look, solving for D, we can see here that sine of theta is equal to D over the magnitude of PQ. That's Q there, right? Yes, it is. And so we can see that D is equal to sine of theta times the magnitude of PQ, or PQ sine of theta, right? Okay, good. So for distance, there it is. How else can we derive it? Okay, we just did it by looking at SOHCAHTOA. Here, we know that PQ times sine of theta is also equal to PQ, the magnitude of PQ, times direction vector M times sine of theta, all divided by direction vector M, the magnitude of it. Notice, guys, that I just multiplied it in, right? And the reason that we do that is because now my numerator is the cross product of P, Q, and M. Okay, and so that's my formula. Another way to look at it, if you're looking at the magnitude of RP, then it's your scalar projection of PQ onto M, and then it's your dot product divided by the magnitude of M. Okay, and QR can be found using the Pythagorean theorem once you know RP. Okay, are there any questions? So this is the formula now that you're going to be using for distance from a point to a line in 3 space. Okay, PQ crossed with M divided by M. Okay, magnitude of M, of course. Okay, so determine the distance between Q to this vector equation of a line in 3 space. So what am I going to do first?
Find PQ, so
Yeah.
Q to the point.
Good. Find PQ or QP, doesn't really matter. And I'm going to do 5, comma 3, comma 0, minus 0, 0, 2. Okay. And so that's going to give me 5, 3, negative 2. Good. And then my direction vector. I have it. I can see it. Negative 1, 2, 6. And then we're going to cross them. Who is that talking for? So 18 plus 4, positive 2 minus 30, 10 plus 3. Good. And then just sub into your formula. So we know that we need the cross product. So there's my magnitude of my cross product divided by magnitude of my direction vector. Who is that boy? You don't recognize that voice? Who is that? That's not Otara. That's a man. Isn't that a man? Okay, so sorry guys, do the math for me here. What do we get?
Square root 1437 over square root 41.
Perfect. And we're gonna just go ahead and round to 2 decimal places. Okay. So guys, again, you're really just plugging into the formula. Any questions? Oh, thank you. Okay, example 5. Determine the distance between the parallel lines. So now you have 2 parallel lines and you got to find the distance between them. Okay, so what are you going to do? You're going to choose any point on one line and you're going to find the distance to the second line. So okay. Okay, so finding PQ. I have 25, negative 8, negative 10, negative 10, 18. 7. Oh, sorry, guys. Hold on. Sorry, guys. Hold on. Hold on. Hold on. I'm writing my direction vector. Yes. Hold on one second, guys. Sorry, guys. Let's try this again. So 20 plus 10. 30. There we go. And now my direction vector. Hold on, guys, one second. Oh, we need help. Okay. Yeah, okay. Hold on, guys, just give me one second. Hold on, guys, just another minute. Help you, that's fine. Sorry, guys. Hold on. Okay, where were we? So choose any point on the first line. We got two parallel lines. Choose any point on the first line and find the distance to the second line. Okay, so here we go. I've got my point PQ. I've got my direction vector M. So now we need to cross the two. Because I want to find that distance between.
Yes, hold on. I'm just getting a question.
Okay, so here I have negative 104 minus 240. I know it's okay, sweetie, don't worry, leave it alone. 285 minus 240. Negative 480 minus 247. Okay, and now we just need to find the magnitude of the, oopsies, of the cross product. Okay, so what do we get here, guys? 34 squared plus 45 squared plus 727 squared. What do we get here? Anyone still with me?
648,890.
Yeah, perfect. Okay, and then at the bottom?
681.
Oh, perfect. Thank you. Okay, and to 2 decimal places, please.
30.87.
Perfect. Are there any questions? Okay. Okay, so let's say now you have 2 lines and they're not parallel, they're skew, and you need to find the distance between the 2 points. So now what do? So here are my 2 lines. Okay, so skew lines means, guys, that they're not parallel, right? They're running in different directions. So what you're going to do is you're going to cross the 2 direction vectors, because we know that by crossing the 2 direction vectors, it's going to give us the normal to both, right? The normal to both. And then we're going to dot it, and then we just have to sub into our formula to find the distance. Okay? All right, so determine the shortest distance between these 2 skew lines. So I need PQ, which here would be 0, 3, 0, right? 2 minus 2, 0 plus 3, 0 minus 0. And then I cross M1 and M2. And so I have negative 4, 0, 5, negative 4, 0, 5, 0, negative 5, 1, 0. Sorry, guys, this is really messy. Okay, so here I have 0 plus 25. And then I have 20 minus 0. Or do I? Hold on. 0, no, 0 plus 4. And then I have 20 minus 0. Okay. And guys, one thing to note here, when you're using these formulas, I don't want you to reduce any vectors, okay? Because we need we're looking for distance, right? So we need their magnitudes to stay the same, okay? So don't reduce your vectors. Okay, so here, now I'm setting into the formula. And I'm dotting with the normal that I found and dividing by. Sorry, I should write it first. Okay, and then you guys can continue from here. What are we left with? 0 plus 12 plus 0, 12 over 25 squared plus 4 squared plus 20 squared.
1,041.
Beautiful, thank you. And then two decimal places. Zero 0.37 square units. Or sorry, square units, units. Cool? Any questions? Now, let's say that you're not told that the lines are skew. Okay, but you notice that they have just different direction vectors. If the lines are skew, you're going to get an actual number for your D. If your two lines are not skew, so if they actually intersect, we know they're not parallel, right? Because we can tell that from the direction vectors. But if they actually intersect, then your D value, the distance, is going to come out to be 0. And then you know that the two lines were actually not skew. Okay? So again, if you're not told that the two lines are skew, and you go ahead and you do this, and you get a distance of 0, that means that the lines intersect. That means they were not skew. Okay? Okay, so now, distance from a point to a plane. Okay, so when we're dealing with the distance here, again, guys, it's the same idea. It's the scalar projection, right? You're dropping that perpendicular, and you're getting the scalar projection, okay, of PQ onto, so hold on, okay, right there. So PQ onto your normal, okay? All right, so we already know the formulas. We've already developed the formula for when we had a Cartesian equation in two space. Well, now we're dealing with equation of a plane, and we do have a Cartesian equation for a plane. And so this is our formula here. Okay, developed, guys, the exact same way that we developed the other one. Okay, notice that we just call D, our constants D, right? And you guys have seen this before. If you go back to the lessons, I can't remember what chapter, I think it was chapter 8, you guys will see where we developed this. Okay, so distance from a point to a plane is this formula. Okay, so calculate the exact distance between the point, 1, 3, -2, and the plane, 4x minus y minus z plus 6. Nice and easy. You're just subbing in A, B, C. You're subbing in your point and your D. We have our D there at 6. So sub it all in. 4 times my x value minus 1 times my y value minus 1 times z value. And then a squared plus b squared plus c squared. Right, which is our normal. Right, the coordinates of the normal. Okay, and so here I'm going to have 4 minus 3 plus 2 plus 6 over 16 plus 2. So if I were to ask for this in exact, of course you would reduce it. If I asked for it as a decimal, there's no need to. And this would be 3√2. And again, I'm going to check to see what the book does, if they rationalize or not. And we're going to be consistent with the book. So if the book rationalizes, then we're also going to rationalize. And there's the approximate right there. Let me check right now. I think what she wants you to do, honey, is to just study because you have a science test tomorrow.
But we're gonna have a test when we finish all the pages.
Okay, but you are finished. You only have one more page. point.
Yeah, I'll move that page.
I know, I have to help you. Just give me a sec. I have to look up the temperatures for you. Give me a second.
It's tomorrow.
Mhm.
It's tomorrow. And nobody knows how to do it.
Don't worry, honey. Okay. Where are we? Magnify. Nope, doesn't look like they're rationalizing, and they're also giving decimals. 1.6. No. No, so we'll be consistent. Well, mind you, it doesn't even matter to you guys. You guys aren't writing a written test. It's multiple choice, but good to know. Okay. All right, example 8. We're almost there, guys. Are you guys still with me? Who's actually still with me?
Yes.
With you.
Okay, we're almost there. There's 9 examples, so 2 more and then you're free, okay? All right, determine the distance between 2 planes. So I have 2 planes, and what we're gonna do is look at the normals of these planes, because you're gonna notice that these 2 planes potentially are coincident, but they are definitely parallel, right? So we have 2 normals. One is a scalar multiple of the other. How do I check if these are parallel and not coincident? What do we do?
Check the D values.
That's it. Just check the D values. So 2 times 2 is 4, 2 times 2 is 4, -1 times 2 is -2, but -3 times 2 is not +9. And so we know that these 2 planes are in fact parallel, okay? So 2 times my first normal vector equals my second normal vector, but 2 times pi1 does not equal pi2. Oops. Therefore, we have parallel planes. So what are you going to do? We have 2 planes that are parallel, and we want to find the distance. So what are we going to do? What do you guys think? We are going to find 1 point on the first plane, and then calculate the distance to the second. Second plane.
Miss, when you say the first plane, we can choose either plane, right?
Yes, you can. Absolutely, you can.
Thank you.
So, to find the point on plane, guys, you guys know, just set x and y equal to 0, and then solve for z, or set y and z equal to 0 and solve for x, right? Or choose whatever random values you want and choose and solve for the other, right? That's how we find points on the plane. Good. So I am going to, so here I'm going to take 2x. I'm calling this my first plane. And I'm just going to let x equal 0, y equal 0, and I'm going to solve for z. But you don't have to do this, right? You can let x and y be whatever you want, or you can solve for x and let y and z be whatever they want. Doesn't matter. All right, so 2 times 0 plus and so we can very clearly see that z is equal to -3. So that means our point is 0, 0, -3. So now we want to find the distance from this point to the plane, and we know the formula for that. We just did it. So there's my A, B, C, and D from my second plane, and I'm subbing in the point from my first plane. And here's my normals. Okay, of the second plane. And we just have to figure this out. 0 plus 0, 6 plus 9. Mm. And if we wanted as an approximate, 2.5 units. And of course, if I ask for it exactly, then you would reduce this, right? Cool? Cool? Any questions?
Miss, I have a question about the textbook.
Sure.
Yeah, I just forgot to ask this earlier.
Hmm.
So if our parents are like busy during the time that we're allotted to go,
Hmm.
like how would we drop it off?
So nobody can go? You're saying that there's no way that you can go?
At least for me, I'm not sure right now because I only have one car available and it's like having car issues, so I'm not sure if I can pick up like.
So what I'm going to say to you is contact the school. I don't know what to tell you. They didn't tell us, they didn't really give us any information. So I would contact the school and find out, say, even if, I don't know if you can respond to an email. I'm not sure if there's an email there that you can respond to, but even just to let them know, right?
Okay.
Because they might, yeah, because what they might do is give you a different, like, is there a time slot that does work for you? They may make an exception for you, right? So you just have to let them know.
Okay. Thank you.
Yeah, I'm sure you're not the only one, right? I'm sure there will be others as well. Okay, last example. The distance from the point P to the plane ax minus 5y plus 2z plus 5 equals 0 is 3. Determine all possible values for a. So now we know what the distance is, but we don't know what the first coordinate of the normal is, right? Our a value. And so we're going to work backwards. So we're going to use that formula. We know the distance is 3. We sub in the point. And then it's a squared plus negative 5 squared plus 2 squared. Okay, so this is what I have. 3 times, 8 across multiply there, right? To solve, I've got 3 times square root of a squared plus 29 plus magnitude of a plus 31. So in order to solve for a, I need to square both sides. So this is going to be a plus 3 squared, right? And so it's a plus 3 times a plus, oh, no, it's not 3. It's 31. I apologize. Okay. And so I have 9 squared plus 261 equals a squared plus 62a plus 61. Okay. And bring this all over to one side, and it's a quadratic. And so I have a common factor here. I can pull out a 2. And when I factor it, what factors do I get? You can factor or use the quadratic formula, right? You're going to get 4a plus 25, a minus 14 equals 0. And so I get a is equal to negative 25 over 4, or a is equal to 14. Cool? Now, be careful, guys, because do you see how we have the absolute value bars here? Oh, jeez. Do you see how you have the absolute value bars here? If we didn't square both sides, you would have to take 2 cases there. Just remember that. We always do that with absolute values, right? Like if you have the absolute value, let's say of x plus 2. Let's say you're solving, right? Then you know you got to take x plus 2 equals 3. So if it's positive, and then you also have to take if it's negative. And you take both cases from there, right? The only reason we don't have to do that is because I've squared both sides. Does everyone see that? If anyone's listening?
Yep.
Yes.
Okay. Sorry, yeah, so just be careful of that, that's all. And that's it, guys. This was the last example. I'll give you your homework in just a sec. Okay, hold on 1 sec, sweetie. Okay, so this is your homework and the review. Note 7B, answer is 3.28, not 3.8, so mistake in the book. And some of the books, the older versions of the book, 9A is also wrong. Okay, if you have a newer one, then I think it's been corrected. And that's it, guys. Chapter 9 is done. The course is done. So again, guys, most of chapter 9, or at least this section, is formulas, and the rest is really solving.